Hello and welcome in this video. And the topic of today's video is the expectation of of a discrete random variable. Okay, we already studied about this random variable and the types of the random variable. Now we are going to discuss about the expectations. So as we know that a random variable is nothing but a function from the sample space to the set of real numbers. And if this random variable is taking some finite value or some countably infinite value, then we can call it a discrete random variable. So in today's topic we will discuss the expectation. How do we calculate the expectation, and or you can say the mean of a random variable. So expectation, okay, so expectation, or you can say the mean, or also you can say that average of a random variable. And with the help of expectation we can also find out the variance. Okay, so we can also talk about the variance, or you can say the standard deviation. And so from here we can also say that these expectation will help us to study about the statistical characteristics of a random variable. Okay, so when we are having a discrete random variable, we generally have the distribution. Okay, so let x be a discrete random variable having having the distribution having the distribution. So the distribution is given as in this tabular form, where the first row of this table contains the distinct values of the random variable x, and in the next row we are having the probability. So you are having something like this, like x1, x2, x3 and so on, and we have the corresponding probabilities here, p1, p2, p3 and so on. So if we are given this type of distribution of a discrete random variable, so the expectation of x can be obtained as summation xi pxi. So what you have to do here, this I will run from 1 to n, means if we are having n values here, so something like this. So what you have to do, you have to multiply each value of the random variable x with their with its corresponding probability, and you have to add all such products and you will get the expectation. And on the same line we can obtain expectation of x square. So again here what you have to do, you just need to multiply this xi square and the probability will remain same here. You have to just take the square of the particular value of the random variable and you have to multiply the corresponding probability. So this is how we can calculate the expectation. Now there are certain properties of expectations. So the properties are, if you are having if you have to find the expectation of a constant c, so it will be the constant itself. Here c is a constant. Okay, so when you are finding the expectation of a constant, so it will be a constant. Now suppose you are taking x, a random variable, and a and b are constants. Okay, so this is, let's say, the property number 2, and you have to calculate the expectation of ax plus b, so that will be a times expectation of x plus b. Okay, so this is how we can calculate the expectation of ax plus b. And similarly, if you are having some x and y as two random variables, so the expectation of x plus minus y will be expectation of x plus minus expectation of y. So here just a condition here, if we need both the expectations to be exist. So if one of them is not exist, then we cannot calculate this expectation of x plus minus y like this. Okay, so this is how we can calculate the expectation. Now we can also talk about the variance. If we have to calculate the variance of x, so this will be expectation of x square, which we have just saw how we can calculate it, and minus expectation of x whole square. So this is how we can calculate the variance, or you can say that sigma square or sigma x square, if you just highlight that this is the variance of the random variable x. Now we can also, if we are having this variance, then you can easily calculate the standard deviation. So standard deviation is certainly defined as the variance of x. So since we know that here we know that variance of a random variable cannot be negative, so it is very much clear that this expectation of x square is always greater than the square of the expectation of x. Now there are certain properties. Okay, so we have certain properties of variance. So if again, if c is a constant, then if you are finding the variance of a constant, so it will be 0. Again here c is a constant. Okay, similarly, if x is a random variable and a and b are constant, then variance of ax plus b will be a square variance of x. Okay, so this is how we can get this, because the variance of b is 0, so this is just a square times variance of x. And similarly, if x and y are two random variables, then variance of x plus minus y is variance of x plus variance of y. Keep in mind that here we are taking the sign as plus minus, but this will always coming out as variance of x plus variance of y, because if you are having, suppose you are having variance of x minus y, so this will be variance of x plus variance of minus y. Now we can use this property. So if you are having a times x, then it will be coming out as a square. So here you can write this as variance of x plus variance of minus 1 times y. So if you further elaborate it like, so this is variance of x and this is coming out as minus 1 whole square variance of y. So this is variance of x plus variance of y. So if you are having minus sign or plus sign, in both the cases you will get the variance as in terms of plus sign. Okay, so this is a very important property, and you should not forget that we have to consider plus here always. Okay, so now let us take the problems on this expectation. So let us discuss some problems on this. So let first problem is the probability distribution of a random variable or of a discrete random variable x is, so we are given this distribution. So distribution is, so we are given like x, px, and we have total 5 values here. So this is -2, -1, 0, 1 and 2, and we have to put it at 0 0.2, 0 0.3, 0 0.3. Okay, so this is not 0 0.3, it is 0 0.1, 0 0.2, 0 0.1, 0 0.3, and here we are having 0 0.3 and 0 0.1, and here with the help of this distribution we have to find, number one, the expectation of x, number two, variance of x, number three, expectation of 2x minus 3, and number 4, variance of 2x minus 3. So we have to find these 4 things. So let us begin with the solution. So we are given this distribution. Now with the help of this distribution we know that, okay, so we know that, okay, so we know that we already discussed that expectation of x is summation x px, or you can write it as xi pxi. Okay, so this is how we are having the formula, and we know that the values are of x are -2, -1, 0, 1, 2. So now we can calculate the expectation as, so expectation of x, so we will take the first value, which is -2, multiplied by the corresponding probability, so it is 0 0.2, plus now the next value is -1 multiplied by 0 0.1, plus next value is 0. Okay, so next value is 0 and the corresponding probability is 0 0.3, plus the next value is 1, so 1 multiplied by 0 0.3 plus 2 into 0 0.1. So from here we will obtain this as minus 0 0.4 minus 0 0.1 if you multiply it, then plus 0 plus 0 0.3 plus 0 0.2. So from here we will obtain this as minus 0 0.5 plus 0 0.5. So this is coming out as 0. So the expectation of this random variable is 0. Now in order to obtain the variance, this second part, okay, so again we know that so we know that the formula of variance, okay, so this is expectation of x square minus expectation of x whole square. So we have already calculated the expectation of x here, so this is our expectation of x. So in order to get this variance we need expectation of x square. Okay, so further, okay, So further, further expectation okay, so further we also know that expectation of x square, so the expectation of x square is summation x square px. Okay, so now we will calculate the expectation of x square using this formula, and once we are having this expectation of x square, then we can easily calculate the variance. So this implies expectation of x square is, so our first value of x is -2, so whole square into the corresponding probability, which is 0.2. You can check here. So this is -2 square into 0.2, similarly -1 square multiplied by 0.1. So next is -1 square into 0.1 plus the next value is 0, and the square of 0 is again 0, and we have to multiply it by the corresponding probability, which is 0.3. Now the next value of x is, if you look at the value, so the next value is 1 and the corresponding probability is 0.3. So the square of 1 is 1 multiplied by 0.3. Now the next value is 2. So when you take the square, so it is coming out 4, and the probability of 2 is 0.1. So this is 4 into 0.2 plus 1 into 0.1 plus 0 plus 0.3 plus 0.4. So in this way we can obtain 0.8 plus 0.1 plus 0.3 plus 0.4. So this will be coming out as 1.6. Now next we will calculate the variance of x. So that will be expectation of x square minus expectation of x whole square. So expectation of x is x square is 1.6 minus expectation of x we have already calculated as 0. So it is 0. So the variance of x is 1.6. Okay, so we have calculated the expectation and variance. Now let us discuss the third case. So here this third case is we have to calculate the expectation of 2x minus 3 and as well as the variance of 2x minus 3. So expectation of 2x minus 3 will be, as we just discussed, the properties of expectation. So using the property we know that this will be 2 times expectation of x minus expectation of 3. Now we have already calculated this expectation of x, which is 0, minus expectation of 3. So 3 is a constant, so the expectation of 3 is 3 itself, and this will give me the expectation of 2x minus 3 as minus 3. Now let us take the fourth and final part. So here we have to calculate the variance of 2x minus 3. So this will be again using the properties of variance we already discussed. So this will be 4 times variance of x, because this 3 is a constant and the variance of a constant is 0. So this is 4 into 1.6. This is variance of x. So this is coming out as 6.4. So this is how we can calculate the expectations and variance. Now let us take another problem here. So here we are given that if x is the outcome of a fair die, then find the expectation of x. Okay, so let us begin with the solution. So again, the sample space, here we are not given the distribution, so here we have to first prepare that distribution, and after that we will use that distribution to calculate this expectation. So the sample space in this case is S, and since we are dealing with a die, so we will obtain this as outcomes as 1, 2, 3, 4, 5 and 6. And since all these outcomes are equally likely, so each outcome has the probability of 1 by 6. So with the help of this information, we can create this distribution, and the distribution is x px, and now again we will write down the values here: 1, 2, 3, 4, 5, 6, and the probabilities for each of these values is same, and it is 1 by 6. Now again we know that, okay, we know that expectation, okay, so here we are mentioning the formula again. So the expectation of x is summation xpx, or again you can mark it as xi pxi. So from this we will obtain this expectation as 1 into 1 by 6. So the first value is 1 and the corresponding probability is 1 by 6, plus 2 into 1 by 6 plus 3 into 1 by 6 plus 4 into 1 by 6 plus 5 into 1 by 6 plus 6 into 1 by 6. So you can take this 1 by 6 as common, and you will obtain this 1 plus 2 plus 3 plus 4 plus 5 plus 6. So when you add all these values, so it is coming out as 21 by 6, or you can say 7 by 2. Now suppose in the same problem we have to calculate the variance, okay, variance of x. So this is also we have to calculate. Now again we know that variance of x, okay, variance of x is expectation of x square minus expectation of x whole square. So we have already calculated this expectation of x, but we don't have the expectation of x square yet. So first we will calculate expectation of x square. So that will be summation x square px, means we have to multiply the square of every value of x with the corresponding probability. So we know that the first value is 1, so square of 1 is 1 and the probability is 1 by 6. Now the next value is 2, when you take the square, so it will be 4 and it is 1 by 6 plus 9, because the next value is 3, so the square of 3 is 9, plus 16 into 1 by 6 plus 25 into 1 by 6 plus 36 into 1 by 6. So we can take this 1 by 6 outside and we left with 1 plus 4 plus 9 plus 16 plus 25 plus 36. So when you add all these values, so it is coming out as 91 by 6. So this is the expectation of x square. Now variance of x will be expectation of x square minus expectation of x whole square. So this is 91 upon 6 minus 7 by 2 whole square, so which gives us 91 by 6 minus 49 by 4. So here you can take 12 as LCM and we have 182 minus 147, and finally this is coming out as 35 over 12. So this is how we can obtain the variance and expectation or the mean of the outcomes of a paradigm. Now let us take one more problem here. So we are given that mean, we are given that mean and standard deviation of a random variable x are 5 and 4 respectively. We have to find expectation of x square and standard deviation of 5 minus 3x. Okay, so this is what we have to determine. So let us begin with the solution here. So we are given that mean and standard deviation. So mean, so we start with the given information. So we are given mean is 5, so this will be same as expectation of x, and we are given the standard deviation. Standard deviation is equals to 4, so this implies variance of the random variable x is 16, because variance is the square of the standard deviation. Further, we know that variance of x is expectation of x square minus expectation of x whole square. So here we are given that this variance of x, we have the value, so this is the value of variance, so it is 16, and on the right hand side we are having expectation of x square, which is not known to us, we have to determine it, and expectation of x is given here. So this is square of 5, so it is 25. So from here you can easily calculate this expectation of x square as 41. Okay, so this is how we can calculate the expectation of x square. Now next we have to calculate the standard deviation of 5 minus 3x. So next we start with the variance of 5 minus 3x, because the standard deviation is the square root of the variance. So this will be because 5 is constant, so variance of 5 is 0, and this will be, you can write it as variance of minus 3x. So this is coming out as 9 times variance of x. So from here we have that the variance of x is 16. So the variance of 5 minus 3x is 9 into 16, which is coming out as 144. So this is how we can find out the variance of this new random variable, which is defined in terms of x. Okay, so let us take one more problem. In fact, this is the last problem of today's video, and here we are given that a random variable has the following distribution. Okay, so the distribution is given to us, and here we are given the values. So we have 8 values. So we are having 0, 1, 2, 3, 4, 5, 6, 7, and the probabilities are 0k, 2k, 2k, 3k, k square, 2k square, and lastly we are having 7k square plus k. Now with the help of this distribution we have to find mean and variance. So let us begin with the solution. So first of all, whenever we came across in this type of problem, so here you can see that the probability is not known to us, it is given in terms of k. So first we will determine k, and in order to find the value of k, we know that summation pi is 1, means when you add all the probabilities of this probability distribution, then it will be coming out as 1. So you have, this implies 0 plus k plus 2k, 2k, 3k plus k square plus 2k square, 7k square plus k is equals to 1. So when you add all these values, so you will have 10k square plus 9k is equals to 1, or you can say that 10k square plus 9k minus 1 is equals to 0. So this is the quadratic equation, and we have to, in order to get the value of k, we have to solve it. So you can this implies you can break it into the linear factors. So the linear factors are 10k minus 1, and the next is k plus 1 is equals to 0. So from here you will obtain the value of k as minus 1 and 1 by 10. But we cannot consider this minus 1, because if k is minus 1, then here many values of x has the negative probabilities, which is not possible. Okay, so we can say that k is equals to minus 1 is not feasible. Okay, so this is not feasible. So this implies we have only one possible value of k, which is 1 by 10. So this is the value of k. Now we have to calculate the expectation of x. So next, expectation of x will be summation x px. So it is 0 multiplied by 0 plus 1 multiplied by k. You can put this value of k here, but I will put it at the last, so it helps me to calculate easily. So this is 2 multiplied by 2k plus 3 multiplied by 2k. The next value is 4 and the probability is 3k. Next is 5 into k square plus 6 multiplied by 2k square plus 7 multiplied by 7k square plus k. So from here we will obtain this as k plus 4k plus 6k, 12k, and from here we are having 5k square plus 12k square. When you multiply this 7 of with this bracket, so this will be 49k square plus 7k. So this gives us, when you add all these values, so this is coming out as 66k square plus 30k. So now we will put the value of k here. Okay, but k is equals to 1 by 10. So this implies expectation of x is 66 multiplied by 1 by 10 whole square plus 30 into 1 by 10. So from here you will have 66 multiplied by 1 by 100 plus 3, and finally you will obtain the expectation of x as 3.66. Next, we will calculate expectation of x square as summation x square px. Why we are calculating this expectation of x square? So this will help me to calculate the variance of x. Okay, so expectation of x square will be, so again 0 multiplied by 0. Now the next value is 1, so square of 1 is 1 itself, multiplied by the probability, which is k. Now the next value of x is 2, so you take the square, so it is coming out as 4, and the probability is 2k plus square of 3, so which is 9, and the probability is 2k plus 16, and the probability is 3k plus 25 multiplied by k square. So this is the square of 5, this is the square of 4. Now the next value is 6, so that will be 36 into 2k square plus, when you square 17, so it is 49 multiplied by the probability, which is 7k square plus k. Okay, so when you add all these values, so it is coming out as 440k square plus 124k. So again, if you put the value of k here, so this will be 440 into 1 by 100 plus 124 into 1 by 10. So this will be 4.4 plus 12.4. So finally we obtained this as 16.8. Now the variance, because we have to calculate the variance, variance is expectation of x square minus expectation of x whole square. So this is 16.8 minus 3.66 whole square, and from here you will obtain it at 16.8 minus 13.39, and this is coming out as 3.41. Suppose so this is how we can calculate the variance of x. Now suppose that if we have to find the standard deviation, so that will be variance of square root of variance of x, so that is square root of 3.41. So this is how we can calculate the expectations, and with the help of expectation we can talk about the mean and variance of a discrete random variable. So this is about the expectation. Next we will discuss about the expectation of continuous random variable. So that's all. Thank you.